This tutorial will introduce one sample test, guide you in selecting the appropriate test for a given dataset, and explain how to run and interpret the results using digital technology. Enumerate the different one sample. The one sample tests are used when we compare a sample statistic to a known and hypothesized population parameter. Some common one sample tests include: first is one sample t-test. One sample t-test used to test if the mean of the sample is significantly different from a known population mean. For example, testing if the average IQ of students in a school differ from national average of 100. Second is one sample z-test. Similar to the t-test but used when the population standard deviation is known and the sample size is large. For example, checking if the mean height of basketball players in a college is different from the national average, given that the population standard deviation is known. Third is chi-square, or goodness of fit test. Determines if a sample distribution matches an expected theoretical distribution. For example, checking if the observed numbers of male and female students in class follow the expected 50-50 ratio. Fourth, the binomial test. Binomial test used for binary or success or failure outcomes to the test if the sample proportion differ from a given population proportion. For example, testing if a new coin is fair by checking whether heads and tails occur when equal probability. And lastly, the run test for randomness. Determines if a sequence of categorical or numerical data points follow a random patterns. For example, testing whether a stock market's daily gains and losses occur randomly over a given period. Decide what one sample test to use given a data set and its hypothesis. When choosing a one sample t-test, consider type of data, continuous or categorical, whether the population standard deviation is known. The hypothesis being tested, scenario appropriate test testing if the mean weight of product is different from the advertised weight one sample t-test. If population standard deviation is unknown, or z-test if known, checking if a coin is a biased binomial test, seeing if your survey responses. For example, customer satisfaction rating. Fit expected distribution, chi-square, goodness, or fit test determine if the series of values occurs randomly runs test for randomness. Examine the chance occurrences of outcomes on repeated trials for a binary variable. For example, fairness of coin. Suppose we flip a coin 100 times and observe 65 heads and 35 tails. We hypothesize that the coin is fair. Heads should occur 50% of the time. We perform a binomial test to determine if the observed population is 65 divided by 100 is equal to 0.65. Is significantly different from 0.5. If the p-value is below 0.05, we reject the null hypothesis and conclude that the coin may be biased. Test whether a series of values is random in a population. For example, stock market randomness, a stock price increases 0 or 1 over 20 days. If the sequence is random, gains and losses should not follow a predictable pattern. A run test for a randomness check if the number of runs switches between 0 and 1 is consistent with the randomness. Examine the difference between an observed sample distribution and assumed population distribution. For example, customer preferences in a store. A store owner expects customers to prefer these categories equally. Electronics 25%, clothing 25%, home goods 25%, and food 25%. A survey showed these actual preferences: electronics 30%, clothing 20%, home goods 35%, and food 15%. A chi-square goodness of fit test determined if the observed distribution significantly differ from the expected distribution. A significant result suggests that customer preferences are not evenly distributed. Run the analysis using digital technology. Several tools can be used to perform one sample test. First is Excel for t-tests, chi-square test, and binomial tests using the built-in function. Second is Python or SPC stat models from SPC import stats sample data, and SPSS or R used for more complex statistical tests and visualizing. Interpret the result of analysis. When interpreting result, p-value is less than 0.05, reject the null hypothesis, significant difference. If p-value is greater than or equal to 0.05, fail to reject the null hypothesis is no significant differences. For example, interpretation. A t-test comparing a sample mean weight to a population mean gives p 0.03. Since p is less than 0.05, we conclude the sample mean significantly differs from the population mean. For conclusion, one sample test helps in verifying assumption about a population based on sample data. By selecting the correct test, running it is using statistical software, and interpreting results correctly, we can make the data-driven decision.